Let's continue. Sorry because of some interruption on my phone. All right. So we up to here just now. How to get this? We take the real part, we'll give that, and the imaginary part will give that one. Now, for the application of the mellin transform to solve the partial differential equation, the difficult part is that to find the inverse of the mellin transform. Yeah, that's pretty difficult. Okay, let's consider this example. I'll try to give whatever I can. So we consider the that problem, okay, where in the wage, you know what wage is. Let me sketch those things. Let's say we have a wage that, okay, this is our theta, and this is our r. Yeah, so r from 0 to infinity, and theta is from 0 to some angle alpha. That wage. Okay, and this is the boundary condition. Yeah. d phi d theta evaluate at phi 0 is 0, and we have some function of r for other value, and phi r theta goes to 0, just remove those infinity, as r goes to infinity. So if you take the Laplace transform of those equation, yeah, so we have 0 to infinity. This is the definition of Laplace, the definition of mellin transform. So r s minus s dr this is the function. On the right hand side we have 0. So now for this part here, you need to split those one by one. This is what I have done. Okay, so we have here, this is from the that equation, this equation here. All right, so we begin from that, and then consider that term by terms. This terms, that terms, and that terms. All right, and then for this term here, you can integrate by parts. You will end up with here. So you do it once, and you need to do it again. And this part here, we cancel out with that. So what left is that and that. And this part, using the boundary condition, that gives you 0. So what you have now is that, so we have this, as I mentioned here, that I mentioned here. We have this part here, and we need to ensure that the integrand term vanish. So we require this part must be 0, because yeah, this part is 0. So what left is only that part. So we consider that part. That will give you the becomes that. So we have d2 phi d theta 2 plus s squared phi equal to 0. This is just a standard second order differential equation. So you can find the solution for this. You can find the general solution. Having the general solution, we can apply to the boundary condition. This is the boundary condition after we do the mellin transform on the boundary condition, and then apply this boundary condition. We obtain the particular solution of that equation. Will give you this. All right. Now, in order to find the solution f, so we need to invert mellin transform. Yeah, apply the inverse of the mellin transform. So to find those things. So this example is up to that. So to find those inverse is given in this example. Yeah. yeah, so we can find the inverse of the mellin transform. So for this part, I think I just leave it to you to learn how to do it. Yeah, the revision is quite long. I don't want to go that in that detail. So I think that's all. And then the latest version or the edited version of the notes I will put in the Botra Blast. Yeah. So basically, I think I have to. Our lecture stop here. This is my last video, and then so basically we have covered three main transformation: the Fourier transform and Laplace transform that I give a pretty detail. But on the mellin transform, I just read whatever we have in the notes, because the nature of the mellin transform is pretty difficult to understand. Yeah. Other information I will let you know by WhatsApp, especially the exam question and so on. Right. So for now, I thank you and very sorry for any inconveniences, any that you feel you might feel not satisfied with my video, with my lecture, and so on and so forth. I'm very sorry. And also well, this is the best we could do for during the MCO, yeah, during the COVID times. Yeah. So yeah, till meet again. Bye bye.